Hello and welcome back to Harry's Jeti Clinic. This is going to be the first of two episodes looking at the ability of the system to detect the state of a switch in the aircraft using the logic in facility that's in your receivers. What do we mean by this? Well, you could fit a physical micro switch, hall sensor in your aircraft to something like in the undercarriage bay, so that it detects when the leg of the undercarriage has actually come up, and only then would it allow you to bring the doors closed. Or it could be, for instance, a nice big canopy hatch. You don't want the locks to operate until the hatch has actually closed. Or you could even use it as an alarm to tell you in flight that the hatch is coming open, something like that. Why would you do that rather than a simple timed sequencer? Well, the problem is sometimes with retracts, the wheels don't always come up in time or properly, or may jam on the way up. And after X number of seconds, of course, your timing sequencer simply tries to close the door on a leg, and the whole thing can get broken, or worse even still, jam with the door on the leg, and then the leg can't come back down. So this is a most useful thing to have. Now, to do this, I'm going to use, I've got a little switch here, simple 2-position switch, ends in a servo plug. You see, we don't wire up the red, we just wire up the data pin and the negative or ground signal, because we can set the receiver to sense whether it's an open circuit or closed circuit between the data pin and the ground. And then in your aircraft, when the wheel leg moves, or the big hatch, the opening canopy moves, or whatever, it can physically move a switch or a hall sensor. That's a sort of magnetic sensor, which of course in some ways is nicer because it doesn't have to physically push the switch. It just senses the magnet getting near. So what we'll do is, and I'll prove that it still works with the older system, I'm using an older R8, not the Rex 8. The Rex 8's, of course, newer than the R series, and it will do the job, but I'm using an R just to prove that it can do it. So what do we need to do? First of all, to sense the state of the switch, let's go into our model, into Device Explorer, choose our receiver, and go into Alternative Pin Config. Now, any one of these can be set to sense the pin. I'm going to choose number 7, and I'm going to change it to a digital input. And that's all it needs. It will now work with the state of the switch. I'm going to plug it into socket 7. There we go. Note, you don't need any separate power source on the plane. It simply senses if you've shorted between the data pin and the ground or not in the state of the switch. So we say OK to that. And now we can come out to Advanced Properties, Telemetry Controls, MX1. What shall we call this? We'll call it leg or gear. Let's call it gear because that's the word that tends to be used now for retracts. Something of an Americanism, but that's the way the world goes. So we'll call it gear. Say it's enabled. Right, now we want, what sensor are we talking about? Let's go in there. It'll be telemetry because of course it's coming back from the receiver. And look at that. It's offering us RX1 input pin 7 because we changed it and it knows about it. So we say OK to that. What type of control is this going to be? Well, it's not asking us what the control is. It's asking us what type of control we want it to be. It's a switch. In other words, it's going to go on, off, or plus 100, minus 100. What's the condition? We want the condition to be x is equal to, not x is less than. Because if we leave it as x is less than and I operate the switch, it's going to be minus 100. There we go. I'll operate the switch. Watch the output doesn't change at all. But if we set it to x is equal to, then lo and behold, if the switch is in the on position, and at the moment it's shorting the ground to the data pin, so it's seeing that as on, plus 100. If I switch it to the off position, open circuit, it's gone to minus 100. There we are. Lovely. The default, by the way, is what will it use if the telemetry signal drops out? You know, when you get told, oh, loss of data or whatever. So just beware that you might want to set a particular value of plus 100 or minus 100 should the telemetry drop out. Say OK to that. And now, see if I operate the switch, watch the state of the telemetry control, and that's reading from what's actually on the aircraft, because that's coming back through the receiver. And now we've got a telemetry control. The world is our lobster, as Del Boy would have said. Was it Del Boy? I think it was. And what can we do with that? Well, in this model, I have got gear and door. I've assigned the gear to my usual switch, so I can switch gear down, switch gear up. Let's suppose this is a simple style where the door is open when the gear is down and the door shuts when the gear is up. If you want the style of, say, a P-51 Mustang, F-86 Sabre, where the doors are shut whether the gear is down or up, and they only open whilst the gear is travelling and then they shut again, that gets a lot more complicated, and we'll deal with that in episode 2. But in this case, the door is going to be a very easy one to do, a simple single logic switch. So we'll assign it to logic switch 1, happily do that, and let's go off and set logic switch 1. Advanced properties, logic switch 1. We'll enable it. Right, think about what's going to happen. There's two things have to be in the up position in order for the door to close. We want the gear switch to be up and the little telemetry control to have registered the fact that the gear has arrived up as well. And then it can close the door. Otherwise, it's got to be open. Easily done with an AND control. So control 1, I'll put my gear switch to the down position, select that, gear switch up, say OK to that. Control 2 will be the telemetry switch. So do that. Telemetry control, MX1, the gear. That's in the minus 100, the down position. That would be the up position. So that's the one we want. Say OK to that. Okie dokie. And we come down, give it an AND control. And there we go. So if I switch the retracts down, we get an off condition. And of course, the micro switch, you'd use a sprung micro switch on the aircraft, would have gone to the off position. When I switch the gear up, it's still in the off position until the leg arrives up and pushes the micro switch, and then that would allow the door to come up. So let's allocate that. I think we did it, didn't we? Yes, we allocated the relevant bits, because we've allocated logic switch 1 to the door. Let's go over and have a look. Okay, whoops, Daisy, I'm trying to watch things through the camera there than in real life. Gear servo, door servo, and here's the switch. We'll start off with everything is in the up position, and gear has pushed the switch up. I'm going to select gear down, watch the door open and the gear go down. Okay, and of course our little spring-loaded switch in the plane would have gone down. Now I'm going to select gear up. The gear will come up, but the door will not close. Okay, and for however long it takes, that door will not close until the switch in the plane recognizes that the gear has pushed on it and closed it, and then there you go. Okay, next you're thinking, all right, so the door's opened and the gears come down at the same time. They might have clashed on the way down. Of course, that would have gone to that position. Well, you can introduce a delay using a sequencer and assign it to the door channel. But if you didn't know it, you can also use slowing and delaying in logic switches. If you go to the servo setup and the servo, you'll find that there's something in there called delay. It's not. It's been misnamed by Jeti. Go into servo setup, go to gear, come down here. It looks like, there, delay. You've got a separate up and a down delay. It's not. It's a slowing. So if we set it to 3 seconds, then as soon as we flick the switch, the servo will start traveling, but it will travel slowly and it will take 3 seconds to reach the end point, which is not what we're after. We actually want it to do nothing for a second or two. That's what a delay actually is. And we can do that in a logical switch. Hooray! Aren't logical switches great? So we'll call this gear delay, or GER delay. You start to find logical switches in Jeti have far more power than simply ands and ors. Okay, go to control 1. Well, that's going to be the gear switch. Okie dokie, because we're wanting to delay the gear. And strangely enough, we don't need a control 2 and we don't need a condition. If I just switch the switch up and down, see, the output is going purely with the input. Now, this is where the beauty of the power of the thing comes in. These symbols and speeds here. This symbol is supposed to be a ramped symbol. If we come to it and click on it, it goes vertical. Click on it again, it goes ramped. If it's ramped, then the time that you put in there acts as a slowing. But if it's vertical, the time that you put in there is a delay until it immediately travels. Now this ramp and time applies to when it switches on. This ramp and time applies to when it switches off. So you can have a delay on switching on, but a slowing on switching off. We want a delay both ways. So we'll say that the on delay is 1 second. On delay, on delay, on delay. Oh, sorry about that. And the down delay, oops, will be 1 second as well. So now when I move the gear switch, it will take 1 second before the state actually changes. And I'll switch it up. There you are. There's actually a delay until it changes. And it changes instantly, not slowly. Say OK to that. It's logic switch 2. So all we have to do now is assign that to the gear switch instead of the actual physical switch. Clear that out. Say past logical switch, gear delay switch. Okie dokie. And there we go. Now let's go back over here. We'll switch up. There will be a 1 second delay until it comes up. We probably didn't need that, but just for the sake of showing it can be done. So I'll, oh, sorry, we're in the down position. Or up. Getting a little bit confused for a moment. All I need to do is reverse the logic switch That's better. Wondered why things were the wrong way around. Okay, and so we start with the gears in the up position. So switch is up, gear is up, door is up. I'll switch the gear down, the door will open. There'll be a 1 second delay before the gear comes down. There we are. And of course the gear would have moved that switch down. Now coming back up, there'll be again a 1 second delay. We didn't need to program it, but we've done it anyway. 1 second delay. Up. There we go. But the door will not close until the gear has finally arrived up and closed that switch. Okie doke. And if you want to slow the door servo down, do that in the servo setup. Go to the door and just change its speed. You've got a separate up and down speed for that if it's servo driven. Obviously, if it's air driven, you're just going to have to go with setting a delay rather than a slowing for it. Okie doke.